BYD have announced that their newest EV platform is going to be capable of charging at up to 1 megawatt of power, which is really an unprecedented jump forward for the passenger vehicle market.
In a market Tesla has long ruled, a bold new player has stepped up, not just to compete, but to double the benchmark. BYD's latest charging breakthrough doesn't just nudge the needle, it rips the gauge off.
When Western automakers talk about an existential threat coming out of China, they're definitely talking about this company called BYD.
We're talking about something so fast, your coffee won't cool down before your EV is ready to roll. But here's the twist. This isn't just about raw power. There's a hidden piece of tech inside BYD's system that flips the entire EV equation on its head. Something even Tesla hasn't cracked, and it's already live. Not a future promise. The numbers are shocking. The method even more so. Stay tuned, because once you see what BYD pulled off, you'll question everything about fast charging. Redefining EV charging power. For years, Tesla has held a commanding lead in EV charging infrastructure, with its supercharger network widely recognized as the gold standard for fast and reliable public charging. The launch of Tesla's V4 Superchargers in 2023, offering up to 500 kilowatts of peak power, reinforced that dominance, setting a high bar for competitors in both hardware performance and network scale. However, in March 2025, BYD disrupted that landscape dramatically by unveiling a charging system capable of delivering 1,000 kilowatts, twice the peak power of Tesla's latest technology. This development represents a direct challenge to Tesla's technological edge and sends a clear message. The EV charging crown is now up for grabs. BYD's 1,000 kilowatt ultra-fast charging capability, demonstrated as part of its Super E platform debut, signals a leap not just in raw power, but in strategic ambition. While Tesla has focused on a widespread, well-integrated charging network, BYD is betting on a future where charging time becomes virtually indistinguishable from gasoline refueling. By achieving a 5-minute charge time for more than 250 miles of range, BYD is targeting one of the biggest psychological barriers to EV adoption, charging anxiety, in a way that Tesla, to date, has only partially addressed. This shift challenges Tesla to accelerate both the technological evolution of its hardware and the speed at which it can deploy higher output chargers globally. The strategic meaning of BYD's announcement is far broader than comparisons of power output. It places China not only as an assembly point for EVs, but as a pace setter for next-generation infrastructure innovation. While Tesla introduced its initial V4 Superchargers in China during 2025, BYD's decision to roll out simultaneously its 1,000 kilowatt technology and expand to a new network of high-speed charging stations provides it with a head start in what promises to be the world's most sophisticated EV charging system. With China already ahead in EV adoption and battery technology, BYD's aggressive move places further pressure on Tesla and other Western automakers to rethink their roadmaps, not only for vehicles, but for how those vehicles are powered. In the end, BYD's foray into the ultra-fast charging arena doesn't merely challenge Tesla's dominance. It redefines worldwide expectations of what EV infrastructure can and must provide. It sets a new benchmark for speed, scalability, and convenience for the user, reshaping what buyers will expect when they drive up to charge. Tesla, which has long been regarded as the pace setter, is now in the unfamiliar role of playing catch-up, at least on the peak performance front. Whether this represents a permanent shift in leadership or sparks a fresh wave of innovation from Tesla remains to be seen. What's for sure is that the competition to control EV charging has begun a new and more combative phase. But raw power is only half the story. What makes BYD's leap truly game-changing lies deeper under the hood. A Kilovolt class powertrain. At the heart of BYD's revolutionary charging performance lies its proprietary 1,000-volt electric architecture, the foundation of its newly unveiled Super E platform. While most advanced EVs from competitors like Porsche and Lucid operate at 800 volts or slightly above, BYD's move to a full Kilovolt class system represents a significant leap forward in EV engineering. This ultra-high voltage platform enables dramatically faster current transfer, which is essential for achieving the company's headline-grabbing 1,000 kilowatt charging speeds. In simple terms, the higher the voltage, the less current is needed to deliver the same amount of power, which reduces heat loss, shortens charging time, and improves overall efficiency. To enable this high-voltage ecosystem, BYD introduced a package of system-level technologies across the vehicle architecture. Among them are specially designed 1,500-volt silicon carbide power chips, which handle energy more efficiently and can endure higher thermal stress than conventional components. These chips are complemented by newly developed electric motors and motor controllers that can handle fast, high-load changes. In addition, BYD redesigned fundamental vehicle subsystems like its power distribution system and even the heating and air conditioning system, all of which were redesigned to deal with kilovolt-level requirements without affecting reliability or safety. What distinguishes BYD is its method of complete integrated design in every layer of the vehicle. Unlike most Western manufacturers that heavily depend on third-party vendors, BYD develops almost every major component, from battery cells to control software, internally. This degree of control enables perfect synchronization among the powertrain, chassis, and electronic systems. By having every component designed from scratch to enable the requirements of megawatt charging, BYD has optimized not only power delivery but also thermal management, system responsiveness, and long-term reliability. This all-around philosophy of design makes it possible for the Super E platform to achieve high-performance driving and quick charging without compromise. The vehicles constructed upon it, like the Han L sedan and Tang L SUV, are able to enjoy super acceleration, stable output during heavy loading, and sustainable top performance with repeated cycles of charge-discharge. But even more importantly, the platform acts as a basis for the scalability of future models and breakthroughs. In setting the bar higher for integrated EV powertrain design, BYD isn't merely challenging the best, it's redefining what best is in the age of electric vehicles. Battery breakthrough. At the core of BYD's ultra-fast charging system is its re-engineered flash charging blade battery, a next-generation evolution of its well-known lithium iron phosphate (LFP) chemistry. Traditionally praised for safety and longevity, but often critiqued for lower energy density, LFP has undergone major upgrades in BYD's new design. Engineers have refined the electrolyte formulation, optimized separator materials, and redesigned electrode structures, resulting in a 50% reduction in internal resistance. These improvements allow energy to flow much more freely through the cell, a critical requirement for accepting the extremely high current levels needed to charge at 1,000 kilowatt without causing overheating or performance loss. This advanced battery chemistry is combined with structural and thermal technologies that enable the blade battery to endure the extreme stresses of megawatt-level charging. In contrast to traditional packs that buckle under high current loads, BYD's new cells can tolerate repeated, safe exposure to ultra-fast charge cycles, partly due to their internal cooling design and distributed energy flow architecture. The flash charging blade is designed not just to withstand brief spikes in power, but to do so with little temperature variation, significantly lowering the risk of thermal runaway and enhancing overall system stability under operation. Just as impressive is the way BYD has made these performance improvements without sacrificing battery longevity or warranty integrity. The blade battery was already known to last tens of thousands of charge cycles, but the flash charging variant takes that as a starting point. Notably, BYD's standard warranty conditions are not altered for cars employing this technology. a reflection of the company's faith in its thermal management and materials engineering. These technological innovations put BYD at the forefront of safe, high-performance electric mobility. Where other manufacturers have trade-offs between charging speed and battery life, BYD has achieved both through chemistry, design, and integration. The flash charging blade battery not only makes the brand's attention-grabbing 5-minute charging possible, it's also a robust, long-lasting solution that may impact industry-wide strategies for high-speed energy storage in EVs. BYD's Megawatt charger. BYD's 360 kilowatt megawatt charger is the most powerful commercially demonstrated EV charging system to date, surpassing all existing public charging stations worldwide, including Tesla's 500 kilowatt V4 Superchargers and the 500 kilowatt Gravity stations in New York. Capable of delivering more than 1 megawatt of power through a single charging port, this system is designed to fully exploit BYD's Kilovolt class electric architecture. In practical terms, it can add over 250 miles, 400 kilometers, of range to a compatible EV in under 5 minutes, setting a new industry benchmark for refueling speed and redefining what's technically feasible in public charging. One of the most impressive aspects of the Megawatt charger is its compact and intelligent design. Despite its enormous power output, the station occupies just 5 square feet, 1.5 square meters, roughly the footprint of a compact vending machine. Even more significantly, it features built-in energy storage, allowing the station to accumulate and discharge energy in bursts without requiring constant high-capacity input from the local grid. This allows for off-grid or weak grid operation, which makes it deployable in areas that would otherwise be inappropriate for such high-output infrastructure. These design aspects have significant implications for energy efficiency and the scalability of infrastructure. With the integration of battery storage, the Megawatt charger offloads local utility loads and can utilize renewable energy sources or time-of-day grid rates. With its compact footprint and modularity, it can be installed in city parking garages, highway rest stops, and off-grid locations with minimal site development. Consequently, BYD's charger not only excels in performance, but also in flexibility, something that current high-power Western chargers tend to be lacking in, due to power and space demands. Looking to the future, the BYD Megawatt charging system provides a template for future-proofing EV infrastructure worldwide. Its scalable design, intelligent power management, and extremely high-performance capability pave the way for a new generation of charging networks focused on speed, efficiency, and convenience. As nations across the globe look to upgrade their electric power grids and eliminate fossil fuel-powered automobiles, BYD's charger can be taken as an example for how to deploy megawatt-scale EV support in the fabric of everyday public life. Beyond its technical innovation, it is a vision of a future where ultra-fast charging becomes accessible to the masses. Dual-gun charging. One of BYD's most practical innovations in fast-charging technology is its dual-gun charging system, available on the Han L sedan and Tang L SUV. These vehicles are engineered to simultaneously accept power from 2 DC fast chargers, effectively combining their outputs to reach charging speeds of up to 500 kilowatts. This is a rare capability in the EV world. While some vehicles have 2 charging ports, BYD's system is one of the first that can actively draw power from both at once. This allows drivers to achieve near megawatt-level charging performance even without access to a dedicated 1,000 kilowatt station. The system is particularly effective when coupled with widely accessible 180 to 250 kilowatt charging stations. To illustrate, connecting a Han L to 2 250 kilowatt charging outlets can supply an aggregate charge speed of approximately 500 kilowatt, whereas 2 180 kilowatt stations can charge approximately 360 kilowatt. The vehicle intelligently splits the 2 inputs, sharing and balancing the power to produce optimized, secure, and simultaneous charging. This enables the charging time to be dramatically shortened using existing infrastructure, even where there is as yet no provision of BYD's own Megawatt chargers. This two-gun configuration provides concrete benefits in areas with underdeveloped charging infrastructure. In most areas, especially outside of major cities, charging infrastructure is capped at mid-range DC fast chargers. Rather than waiting for higher output infrastructure to materialize, BYD's two-gun system allows drivers to maximize what is already available. This also future-proofs the vehicles by ensuring compatibility with a wide variety of available and next-gen charging hardware, providing consumers more flexibility and eliminating dependence on any one charging vendor. Ultimately, double-gun charging showcases BYD's focus on pragmatism in real-world usefulness and expansiveness, as opposed to gimmick-driven publicity stunts. Sure, megawatt charging will be the new standard in quick energy injection to come, yet double-gun capability fills in between the dream book and the practical nowadays. Double-gun capability brings fast charging out into the majority of everyday conditions on the ground more frequently and further enhances overall user convenience in utilizing electric transport within the regions yet to witness increased infrastructure establishment. But if you think dual-gun charging is impressive, wait until you see what happened when BYD put its full power on display, live, unfiltered, and faster than anyone expected. BYD's live demonstration. At the Beijing demonstration held in early 2025, BYD showcased its revolutionary Megawatt charging system in a real-world scenario, offering a rare glimpse into the performance of its new Super E platform and flash charging blade battery under actual conditions. A Han L sedan, equipped with BYD's proprietary 1000-volt architecture, was connected to a BYD Megawatt charger, and the results were broadcast live to an audience of media and industry insiders. As the charging began, the vehicle's display instantly showed a charging rate of 1002 kilowatt, a figure almost unimaginable just a few years ago. While this peak was maintained only briefly, the taper curve that followed still held impressively high rates, 767 kilowatt as the battery hit 30%, then 633 kilowatt at 40%, and 463 kilowatt by the time it reached 60.1%. This progression wasn't just fast, it was stable, efficient, and a clear demonstration that BYD's system could deliver sustained high-speed charging, not just theoretical bursts. The figures BYD reported during this demonstration weren't hype, were measured in real time, under repeatable and measurable conditions. The car began with a 13% state of charge, and in less than 5 minutes, it had achieved 60.1%, which corresponds to an addition of some 262 miles, 421 kilometers of range. These numbers weren't just indicated on the car's dashboard, but were also monitored in real time using a projector projecting the car's energy consumption curve. Significantly, these rates weren't the result of dual-gun charging or, with special conditions, of a single plug, and BYD's Megawatt charger. That the charge rate increased so rapidly and held at a high rate before dropping off gradually implies that the underlying battery chemistry and power management systems were operating precisely as intended, without any artificial staging or intervention. What's remarkable about this demonstration is that it was genuine world proof of BYD's engineering assertions, something that very few automakers can or are willing to perform on this kind of scale. It's one thing to offer laboratory data, internal simulation, or controlled condition test results, but it's another to achieve that performance under real-world conditions in front of an audience with no leeway for error or fudging. The test's successful result validates BYD's 1000-volt system, its revamped thermal management, and its capability to provide megawatt-grade charging without injuring the battery or heating up the system. These are the sorts of statistics that matter most to dubious customers and industry players alike, evidence that the technology works not merely on paper, but in real life. More generally, the Beijing demo is a landmark moment in the history of EV fast charging, putting BYD at the vanguard of a technological revolution that can transform global expectations. It announced that the EV experience no longer needs to feature long queues at public chargers or sacrifice driving range to accommodate slower refueling times. With this successful 5-minute charging test, BYD not only demonstrated that these speeds are feasible, it made them a reality. For car manufacturers, regulators, and infrastructure planners everywhere, this demonstration is an urgent call to action. If BYD can do this today, then the future of rapid charging is not 5 or 10 years off. It's now, and it's moving rapidly. Managing the heat. As electric vehicle charging speeds climb into the megawatt range, thermal management becomes one of the most critical engineering challenges, and BYD has approached this with a level of innovation that matches the scale of its charging ambitions. At the center of BYD's cooling strategy is a direct refrigerant battery cooling system, a sophisticated method that uses liquid refrigerants rather than air or traditional liquid coolant to extract heat directly from the battery cells. This system is far more efficient at rapidly dissipating heat generated during high current charging events, ensuring that thermal loads are managed in real time. By targeting heat at the source with this precision, BYD eliminates the lag and inefficiencies often associated with indirect or passive cooling systems. What makes this solution so effective is its integration with the Blade battery's unique structural design, which inherently supports superior thermal stability. The Blade battery uses long, flat cells arranged in a way that increases surface area for heat transfer while minimizing internal gaps where heat could build up. This layout, combined with the direct refrigerant cooling, enables the battery to sustain extremely high charge and discharge rates without risking thermal runaway, a dangerous condition where excessive heat leads to uncontrollable chemical reactions and potential fire hazards. BYD has effectively designed a battery that can not only endure intense thermal stress, but also do so safely and repeatedly. The benefits of this thermal system aren't hypothetical, they're quantifiable in terms of performance and lifespan. In accordance with BYD, the new Blade battery employed in its flash-charging electric vehicles has a 35% longer lifespan in hot temperatures than earlier models. This is effective in that, even with repeated ultra-fast charging, where heat production is most aggressive, the battery is kept intact and retains its energy-holding capabilities. The minimized degradation over time also allows drivers to take advantage of high-speed charging without the fear that it will speed up battery wear or detract from long-term reliability. It's a big confidence boost in an industry where the fastest solutions have sometimes had the biggest risks to battery health. Fundamentally, BYD has constructed an integrated heat management system that makes high-speed charging a technology in reality instead of theory for universal adoption. The blending together of innovative materials, strategic cell packaging, and next-generation cooling makes BYD's battery solutions not only very high performance, but extremely durable too. While the industry hurries toward the speed of quick charging to leave range and waiting time fears in the dust, BYD's effort highlights a significant truth. Speed is insufficient on its own. Without correspondingly sophisticated safety and cooling technology, high-speed charging would remain an unsubstantial promise. But BYD has demonstrated that, under proper engineering, it can also be a working, dependable, normal fact: BYD's lightweight charging gun. While BYD's advancements in high-speed charging have rightly drawn attention for their technical brilliance, one of the most thoughtful and practical innovations lies in a much smaller detail: the ergonomically designed charging connector, or gun. Weighing just 4.4 pounds, 2 kilograms, this redesigned charging plug is significantly lighter and more manageable than most of the connectors currently used in Western markets. This design isn't just about aesthetics, it's a deliberate step toward making ultra-fast charging more comfortable, intuitive, and user-friendly, particularly for individuals who may not have the upper body strength to handle bulkier hardware. BYD's slimmed-down grip and lightweight build were designed with accessibility foremost in mind. As a matter of fact, EV charging equipment in much of the world, particularly North America and Europe, has tended to be engineered with industrial strength toughness in mind, but at the cost of everyday practicality. BYD engineers have approached the problem differently, understanding that a wider population, including older users, women, and individuals with reduced physical mobility, ought to be able to interact with high-power charging systems without frustration or physical effort. This design consideration serves to eliminate one of the nuanced, frequently unnoticed impediments to EV adoption: the physical effort of connecting a heavy, cumbersome fast charger. Compared to the ubiquitous Combined Charging System (CCS) plugs that dominate much of the Western world, BYD's connector seems an ergonomic step in the right direction. CCS plugs tend to be bulky, inflexible, and awkward to handle, particularly when connected to heavy cables with thick insulation necessary to support high voltage and current. This can render plugging in an EV a slow and fumbling process, especially in cold weather or dark areas where dexterity is reduced. BYD's connector, by comparison, has been engineered to be simple to hold, orient, and engage, even for a quick stop to charge, transforming what previously was a fumbling, mechanical interaction into one that is less clumsy and more human-friendly. Finally, the usefulness of BYD's lightweight charging gun extends far beyond convenience. It is a sign of a wider movement toward user-driven EV design, wherein leading technology is not only capable but also accessible. By solving real-world user requirements at every level, both from the vehicle platform to how a plug feels in your hand, BYD is striving to make the EV experience as easy to use and as intuitive as it possibly can be. By doing so, the company is not only breaking the limits of performance but also reducing the entry barrier for millions of future new EV drivers, building a future where rapid charging is not only rapid but also welcoming. China's charging expansion. As part of its broader strategy to lead the global EV market, BYD has committed to building 4,000 ultra-fast megawatt charging stations across China. This ambitious initiative is directly aligned with the launch of its 1,000 kilowatt Super E platform and is intended to create a national infrastructure that can support the company's groundbreaking 5-minute charging technology. BYD's vision goes beyond simply enhancing convenience for its customers. It aims to reshape public perception around EV practicality by erasing one of the most persistent barriers to adoption: long charging times. By aggressively expanding its proprietary network, BYD is ensuring that its vehicles have the infrastructure support necessary to perform at their full potential, setting a new gold standard for what a vertically integrated EV ecosystem looks like in practice. In comparison to Western initiatives, BYD's deployment strategy is not only more ambitious, but also more centralized and integrated. Tesla, traditionally the EV charging infrastructure leader, has made significant progress with its supercharger network, such as the launch of 500 kilowatt V4 Superchargers. Yet Tesla's build-out is still relatively modest in scale, particularly in China, where BYD is quickly closing the gap. Conversely, the IONNA Consortium, a collection of traditional automakers such as BMW, GM, Honda, Hyundai, and others combined in a joint venture, has yet to achieve critical mass in the US, with only a few dozen sites announced and none operating at the 1,000 kilowatt scale. BYD, by contrast, already has 500 megawatt stations in operation, and its goal of 4,000 represents a deployment rate not seen among its international rivals. One of BYD's greatest strengths in expanding its charging network is that it is vertically integrated through the entire EV value chain. As opposed to many Western automakers that must rely heavily on third-party suppliers for anything from battery manufacturing to charging hardware, BYD develops and makes its batteries, electric motors, software systems, and charging stations internally. This close control over both vehicle and infrastructure development allows for quicker cycles of innovation, efficient deployment logistics, and hassle-free compatibility among hardware components. Consequently, BYD can easily deploy high-speed chargers that are completely optimized for its automobiles without the slowness, coordination problems, or interoperability issues typical in decentralized, multi-vendor environments. This vertically integrated strategy not only enables BYD to grow more quickly, but also puts the company in a position to establish the technological benchmark for public charging infrastructure, especially in China's densely populated urban areas and growing highway networks. With government incentives for NEV, new energy vehicle, adoption, robust domestic manufacturing capacity, and growing consumer demand, BYD is well positioned to implement its infrastructure growth at a scale and pace that would be unparalleled by most competitors. The deployment of these 4,000 megawatt stations will not only power BYD's expanding fleet, but also establish the foundation for an EV infrastructure model that could be exported or replicated worldwide. By doing so, BYD is not just preparing for the future, it's actively shaping it. But BYD's infrastructure play isn't just about speed and scale. It's setting off alarms far beyond China's borders. Global ripple effects. BYD's introduction of 1,000 kilowatt megawatt charging technology, combined with its Kilovolt class Super E platform and nationwide infrastructure ambitions, is poised to send powerful shockwaves through the global automotive industry. For Western automakers who have long considered Tesla the benchmark in electric vehicle innovation, BYD's rapid technological leap serves as a wake-up call. This isn't merely about charging faster, it's about rethinking what an electric vehicle platform should look like, from the battery chemistry to the plug design to the national grid-level strategy. Western OEMs, especially those relying on legacy platforms or slower infrastructure rollouts, now face pressure to match or exceed BYD's innovation curve or risk falling irreversibly behind in both performance and perception. Additionally, regulators in the US and Europe who have been cautiously optimistic about their EV goals may need to accelerate policy frameworks to support or incentivize the development of megawatt-class charging infrastructure and higher voltage EV platforms. The effect of BYD's breakthrough is bound to go far beyond competition and reach into collaboration and licensing. While global demand for high-speed charging solutions increases, manufacturers that can't or won't invest in equivalent R&D might turn to licensing parts of BYD's platform, battery technology, or charging infrastructure. This provides an opportunity for BYD to not only export cars but whole technology stacks and become an upstream provider of advanced EV solutions. Concurrently, we will probably witness a technology race where Hyundai, Mercedes-Benz, Volkswagen, and GM will be competing to create or acquire equally capable architectures. Startups and silicon carbide chip specialists, thermal management, and kilovolt power electronics suppliers might notice new opportunities for growth as worldwide OEMs step up their move to counter competition. In addition, BYD's experience will encourage the restructuring of worldwide EV supply chains, as carmakers look for suppliers who can make parts ready for increased voltage and higher charging speeds. More generally, BYD's success is a turning point not only in product performance, but in EV leadership worldwide. For decades, China has been considered a manufacturing titan, an integral part of the global supply chain for EVs, but seldom the source of cutting-edge innovation. BYD's Megawatt charger breaks that pattern by positioning China as the leader in EV technology and infrastructure innovation. It indicates that Chinese automakers are not merely catching up with their Western rivals, they're starting to lead the way. This shift has the potential to have profound effects on the dynamics of the global market, particularly as emerging nations weigh what EV standards to adopt and whose technology to incorporate into their own grids and codes. If BYD's system prevails as a model in Asia, Latin America, or certain regions of Africa, Western car makers could find themselves on the outside looking in. Finally, what BYD did was recalibrate the assumptions around what electric vehicles can provide, not in 5 years, but immediately. The spin-off from this innovation will impact engineering groups, boardrooms, government policy forums, and consumers' expectations. Car makers that don't get this won't be long-term winners, but losers, once being good enough, doesn't become enough. Conversely, those who see BYD's innovation as a game-changer and act with a sense of urgency have an opportunity to redefine their approaches and stay in the game as the landscape shifts at breakneck speed. Either way, BYD has created a new narrative, one where China is no longer the imitator, but increasingly the pace-setter in the world EV race. If this blew your mind, just wait until you see what's next. Drop a like if you're excited about the future of EVs, leave a comment with your thoughts on BYD versus Tesla, and don't forget to subscribe for more breakthroughs you won't hear anywhere else. Hit that bell so you never miss a charge and tap the next video on your screen to keep the current flowing.